This is part 2 of our series on reaction times. If you haven't seen part 1 yet, where I give you the foundation to understand this material, I highly recommend that you go back and watch that first, since I'll be referencing a lot of that material in this video. So we've learned how your brain can save you precious time in a survival situation by bypassing the slower, more computationally heavy parts of your brain, like the cortex. But what about for athletes or gamers who want to improve their reaction time? They're usually not working in a survival situation, so their bodies probably wouldn't need to kick into that fight or flight response. Plus, you probably wouldn't even want the fight or flight response because your movements might not be as refined or accurate as you would like since you're in a state of panic. So what do? How do you improve your reaction time while maintaining that accuracy? There are 2 main components to this. The first one is hardwiring your movements until your brain almost goes quiet. I'll explain what that means in a moment. And number 2, tricking your brain into responding faster than it thinks it can. Okay, let's start with the first one, hardwiring your movements. You have to practice your movement so much that it becomes instinctual, almost like a reflex. When a new basketball player is learning how to dribble, they're using a lot of their brain to figure out the right timing and coordination. Their outer cortical layers that typically take more time to process information are working hard to figure out the movement patterns and timing that's required for dribbling. Each time this player practices a specific movement, certain neurons in their brain shift to form stronger connections with each other. The player is literally hardwiring this specific movement by creating strong neural connections, a strong neural pathway that's dedicated to this movement. According to a number of studies, it seems like they're building this specific pathway in the older, deeper structures of the brain that can respond very quickly and automatically to stimulus. These studies indicate that once a player becomes proficient at this movement, their outer cortical layers aren't as active as before. They go quiet. The player is now only relying on those neural pathways that they've hardwired into the deeper brain structures, the structures that respond automatically to stimulus. The player experiences a shift from having to make a conscious choice about their movements to reacting without any thought. This directly improves their reaction time because they no longer have to make a conscious decision about their movements. But studies are also finding that if the movement gets more complex, there are more variables to consider, then the player's outer cortical brain regions activate again. The player might be navigating multiple defenders and trying to spot their teammates to pass the ball. This requires visual spatial orientation, visual searching, motion observation, and other pretty complex cognitive tasks. They'll likely have slower reaction times during these complex dynamics. So the goal is to automate as much as possible to have the best chance of having a fast reaction time in as many scenarios as possible. Automating your movements gets you much closer to your fight or flight response time, but it's still not quite as fast. Let's take a look at the second component, tricking your brain into responding faster than it thinks it can. Some studies found that there's actually a 70 millisecond gap in between when we mentally prepare our movement, the preparation phase, and when we initiate the movement, the initiation moment. So in other words, they found that we were sitting there for 70 milliseconds doing nothing before we actually started to react. Let's see how the researchers figured this out. Researchers had participants try to touch a target as soon as it appeared on their display. On average, their reaction time took about 200 milliseconds. That's for them to just start initiating their movement. 200 milliseconds. Remember how long it took for us to start pulling our hand away from that hot pan? 15 to 30 milliseconds. Now you'd think that the participants are responding as fast as they can, right? The participants thought so, but it's not necessarily the case. Researchers figured this out by changing the experiment slightly. They told the participants that they had to start moving the moment they hear a sound go off. So the moment you hear a sound, go. The target would sometimes appear well before the sound, giving the participants plenty of time to mentally prepare their movement. The participants would be like, okay, I see the target, I'm ready, I'm just waiting for that sound. and the moment the sound goes off, boom, they go. But other times, the target would appear right before the sound went off, or right when the sound went off. So the participants would almost be moving blind in these cases. Try it for yourself. In this manner, researchers pushed participants to move faster and faster. Eventually, they were moving so fast that they started losing their accuracy. They just couldn't keep up with it. This moment, when accuracy starts to drop, indicates how much time roughly is required for a full preparation phase to properly prepare your movement, because anything shorter than that and you start getting errors. This paper estimated that it takes about 132 milliseconds to fully prepare your movement for that full preparation phase to take place. So if it takes you 200 milliseconds to react to that target appearing, then there's a 70 millisecond gap where your brain seems to be preventing you from initiating your movement. On average, there's a 70 millisecond gap where you're seemingly doing nothing. What? Why is our brain keeping us from initiating our movement right away? Why are we waiting 70 milliseconds? Well, there may be an evolutionary reason for this. The researchers theorize that perhaps delaying the movement initiation buys extra time for one to make adjustments as new information is realized, or for a late change of mind. This basically could be a protective mechanism to allow you more time to reconsider your movements or to make adjustments. But here's another really interesting finding. Other studies found that if you startle the participant, they'll respond 70 milliseconds faster than they otherwise would have. Now, there's a chance that this could be coincidental. This 70 millisecond quickening was observed in a different study with completely different test parameters. But there's also a chance that there could be a correlation of some kind. Perhaps in this startle response, if the brain deems it a survival requirement, it seems willing to shave off those 70 milliseconds. But can you shrink this gap without having to be startled? Actually, yes. When those researchers forced participants to respond faster by having to move the moment they heard the sound go off, those participants' reaction times improved dramatically. As they were forced to respond faster and faster, the participants' reaction times dropped by like 30 to 60 milliseconds before they saw any errors creep in. Wow. They basically shrunk that gap between their preparation phase and the initiation moment to nearly what they would do in a startle response. So it seems like putting that time pressure on yourself, if you can do it right, can dramatically improve your reaction time. Now, the pro athletes probably get why 70 milliseconds is such a big deal when it comes to reaction time. But for the rest of us, we need to get caught up on why that small fraction of a second is worth pursuing. Professional baseball has a fantastic example. I'm sure a few of you know where I'm going with this. Some of these pitchers are known to throw crazy fastballs. Some of these are reaching speeds of over 90 miles per hour. A few of the pros have been documented to throw even over 100 miles per hour. And you're expected to hit that thing with a bat? For the vast majority of us, it's an impossible feat. If that ball is traveling at almost 100 miles per hour, it'll reach the batter in about 400 milliseconds. Remember, a blink takes about 400 milliseconds. So this 70 millisecond gap that your brain creates is huge. It's almost 20% of the total time it takes for that ball to travel to you. And then you have boxing. People can throw punches that make contact in as little as 60 to 100 milliseconds. You can barely even see the punch at that point. That's insane. So if you're sitting around for 70 milliseconds, you've missed the punch entirely, and you're probably already knocked out. The pros out there have found ways to respond to these fast-paced movements. I bet you they found a way to reduce this lag time. They also have trained these movements over and over, swinging the bat, dodging that punch. They've trained that movement so much that it's been committed to an almost reflexive response. So what can you do to improve your reaction time? Firstly, training that very specific movement over and over again until it becomes almost reflexive. You've got to install it. A number of studies have found that even slight variations from that trained movement will cause more parts of your brain to activate again so that they can analyze this new part of the movement. This will add significant time to your total reaction time. So train your movements exactly how you'd perform them in a real situation. Secondly, finding a way to reduce that 70 millisecond gap, that lag time that your brain often demands. This can be a hard one to train. It can be difficult to design practice environments that apply a time pressure to your reaction, especially when the movement's already so fast. I mean, how do you make it faster? Well, people are getting creative and have found an interesting solution. They're called Strobe spectacles. This is Jarvis Landry, an American football wide receiver. Now, these are snippets from a promo video by Synaptec, where they demo their Strobe glasses. These glasses flicker between clear and opaque. It almost replicates an eye blink. It basically blinds you momentarily with each flicker. This, in a way, reduces the amount of time and information you have to plan and initiate your movement. It puts pressure on you to make a decision without as much information. Athletes will train while wearing these, and it's challenging. It puts them outside their comfort zone and forces them out of their habitual movement patterns. After training with these for a period of time, the athletes will then take them off and test their abilities. And studies show good results with this technology. One study showed that athletes' hand-eye coordination, that reaction time, improved by more than 10%. So how do they work? There's no clear explanation currently. I mean, we have ideas, but there's nothing concrete. I have a feeling it's connected with what we learned earlier, though, that reducing the amount of time you have to process information forces you to reduce that 70 millisecond lag time. Plus, this gap might be a comfortable habit. These glasses break up that habit and force you to learn how to react in a different way. If you want to try these glasses for yourself, I'll provide a link to some in the description so that you can do more research. Other alternatives to the glasses are to establish practice sessions to replicate what those glasses would offer you. You could close your eyes for a moment or two to basically reduce the amount of time that you have for visual processing. Or you could apply other forms of time pressure. This may depend on your particular sport or game, so you may have to get creative with this. But you could play with setting a timer for yourself, where you have to complete your movement within that set time. And then you can shrink that time down further and further until you find yourself making errors. Training in that challenging zone that pushes you outside of your habitual patterns could be enough to help you shave off a number of milliseconds. So here are your takeaways. Number one, be relentless with training your movements. Get them hardwired. And you want to be clear about training specific movements. Even slight variations from what you trained could cause you to move slower since it's not exactly what you practiced. Secondly, find ways to reduce the amount of time that you have to respond. Maybe you blink a bunch. Maybe you set a timer for yourself and you consistently shrink that time that you have to respond until you find that really challenging zone that pushes you outside of your typical habitual patterns. Train that for a bit and see what happens. The understanding of reaction times from a neuroscience perspective is still fairly new. New discoveries are constantly challenging old assumptions. So check back in for future updates on the latest discoveries on this topic. If you want to support future videos, subscribing to the channel is one of the best ways you can help. What are some of your experiences with improving your reaction times? Or have you had a spidey moment where you reacted so fast that you surprised yourself? Share your experiences in the comments. It'll be really interesting to see what you all have discovered. I've been working on a follow-up video to this one that covers the second half of a reaction, the actual movement. So one of the questions we'll be asking in this video is what kind of training can you do to improve the speed of your movements? Once it's uploaded, it'll be linked here. I'll see you then.